Welcome to this explainer. Today, we're looking at something absolutely fascinating. We are quite literally looking at the blueprint for our future. The European Innovation Council just released their 2024 tech report, and it spotlights 34 groundbreaking emerging technologies. And listen, we aren't talking about some distant science fiction movie here. We are talking about real innovations in development right now that are going to completely redefine our industries, our economies, and honestly, our daily lives.
So that begs a pretty massive question. How exactly will these 34 emerging technologies solve humanity's greatest challenges? I know it sounds like a dense, intimidating report filled with scientific breakthroughs, but don't worry, today we're going to distill the whole thing down. We'll explore exactly how these innovations are practically designed to tackle the global crisis we're facing today, from climate change to chronic disease to digital bottlenecks.
Okay, let's dive into this. We're going to structure our journey today through the four main domains the EIC identified. First up, powering a green future. Second, the next era of healthcare. Third, connected and quantum worlds. And finally, the collaborative ecosystem.
All right, Section 1, Powering a Green Future, Environmental Survival.
Our environmental survival quite literally depends on transitioning away from old, highly polluting methods over to revolutionary green tech. And just look at the sheer volume of innovation happening right now. In agriculture and materials, we've got plant-based biomanufacturing and triparental plant breeding, which actually creates climate-resilient crops without genetic modification. We're also seeing biohybrid sensors and artificial CO2 photosynthesis. And for heavy industry, we're talking sustainable aviation fuels using liquefied hydrogen to decarbonize the skies, along with the electrosynthesis of urea. These are genuine engineering marvels happening today.
Now, what's really interesting about this slide is how we are completely rethinking one of the most energy-heavy industries on Earth, fertilizer production. Traditional methods are just incredibly energy-intensive and carbon-heavy, but the electrosynthesis of urea, it flips the script entirely. It replaces that old, dirty model with an eco-friendly process that co-reduces carbon dioxide and nitrogen under ambient conditions. We're talking about meeting massive global fertilizer demand while actually reducing energy consumption. It's a total game-changer.
This brilliantly illustrates how the best answers often come from mimicking nature itself. Take artificial CO2 photosynthesis, for example. It works in 3 surprisingly elegant steps. Step 1, you capture the carbon dioxide. Step 2, you mimic the natural process of photosynthesis that plants have already perfected over millions of years. And Step 3, you convert that captured CO2 into storable renewable fuels. It is a brilliant dual-threat solution. We're literally pulling carbon right out of the atmosphere and creating clean energy storage at the exact same time.
And speaking of plants, these biohybrid sensors are completely mind-bending. Basically, these are self-powered, plant-based sensors designed to monitor environmental factors. Think things like water stress or specific nutrient needs in real time. Imagine a future of precision agriculture where your crops are essentially texting you exactly what they need, the exact moment they need it. It completely optimizes our global resources for a truly sustainable world.
Moving right along, let's jump into Section 2, the next era of healthcare, combating undruggable diseases. Let's move to and see how this builds a completely new medical landscape. The stakes here are incredibly personal. It's the fight against chronic, previously untreatable, and quote-unquote undruggable conditions. For diagnostics, we've got metabolomics revealing disease-specific metabolic signatures and digital biomarkers predicting health with AI. For treatments, there are massive breakthroughs like targeted protein degradation and flash radiotherapy. And for physical recovery, we're seeing in situ bioprinting and 4D bioprinting using self-healing materials. Medicine is rapidly shifting from just reacting to illness to being highly personalized and predictive.
To see just how dramatic this shift is, let's contrast a standard treatment with a new one. Standard radiation therapy, while life-saving, often causes unavoidable damage to surrounding healthy tissue, right? Plus, it requires prolonged treatment times. But enter flash radiotherapy. This emerging technology delivers ultra-high-dose radiation in mere milliseconds. Because it happens so blazingly fast, it vastly minimizes the damage to healthy tissues and radically shortens treatment times, making cancer care far more accessible and way less grueling for the patient.
And then we have targeted protein degradation. This step's completely outside traditional pharmaceutical approaches. Step 1, we introduce these highly innovative molecules into the body. Step 2, these molecules specifically hunt down and target disease-causing proteins. Step 3, they completely eliminate targets that were previously considered undruggable. We are literally learning how to attack the deep root causes of complex oncology cases and severe neurodegenerative diseases.
Now, if we need to physically repair the body, the blueprint gets even wilder. In situ bioprinting is the direct printing of tissues onto or even within patients for personalized injury and organ repair. Just think about that for a second. Instead of waiting for a donor organ or relying on a prefabricated artificial implant, medical professionals could directly print the necessary, personalized biological tissue right where your body needs it to heal. It completely revolutionizes surgery and recovery.
All right, Section 3, Connected and Quantum Worlds, Processing Power and Connectivity. Here's the catch. To make all these green and health innovations possible, we need serious computational muscle to manage massive data bottlenecks. The backbone of this quantum-powered infrastructure includes hardware leaps like single-atom photocatalysis and photonic integrated circuits, which actually replace traditional wires with light. Then we have brain-inspired neuromorphic chips. It also includes agentic AI capable of decentralized decisions, fault-tolerant quantum systems, and a whole new web of low Earth orbit satellites for global connectivity.
A great example of this evolution is happening right in the hardware. Standard computer processors have taken us incredibly far, sure, but they consume vast amounts of energy, especially when they're running AI. Brain-inspired neuromorphic chips literally emulate human neural processes. By physically structuring the chip to process information more like the human brain, we're looking at a massive breakthrough in energy-efficient AI and real-time computing. This is absolutely vital for things like autonomous vehicles.
Then, of course, there's quantum computing, the holy grail of processing, right? But it's famously unstable. That's why the focus is on fault-tolerant quantum systems. These are advanced computing systems specifically designed to address huge challenges like noise and decoherence. So the crucial point is this. Without solving those issues of noise and decoherence to make the systems fault-tolerant, reliable, scalable, real-world quantum applications just wouldn't be possible at all. This tech is what finally unlocks the quantum era.
We also got to think about where all this computing actually happens. The cloud is great, but it requires sending data back and forth, which creates latency and uses huge amounts of energy. Edge AI solves this by bringing the computational power directly to the data source, the edge of the network. It's kind of like cooking a pizza in your own kitchen instead of waiting for a delivery from a factory 10 miles away. It minimizes latency and vastly improves energy efficiency for the billions of IoT devices connecting our smart cities. Finally, Section 4, the collaborative ecosystem.
You know, here is the real secret to everything we've discussed today. Not a single one of these 34 technologies exists in a vacuum. A biohybrid sensor needs edge AI to process its data. Synthetic digital twins of cities need low Earth orbit satellites. Success requires intense, interdisciplinary collaboration. As the European Innovation Council sums up perfectly, these emerging technologies are more than scientific milestones. They are pathways to addressing humanity's most pressing challenges. This isn't just a list. It's a cohesive, interconnected blueprint for a smarter, healthier, and far more sustainable world.
So I want to leave you with this one thought as we wrap up our explainer today. We clearly have the blueprint for tomorrow, but are we actually ready to build it? Are our industries, our policies, and our societies ready to embrace the massive shifts required to bring these incredible innovations to life? It's a huge question, and one we all really need to be thinking about. Thank you so much for exploring this fascinating roadmap with me today, and keep learning.